All right, hello everybody. I'm away today because I have a meeting, or I can't be here, but I have a little lesson for you to make supply day go as smoothly as possible is the hope, the dream. So here we go. I actually changed the order a little bit. We did 15 yesterday, and then a little trickier, so I'll be there for that one. This type 2 mixture problem is actually similar to what we did on Wednesday. I just didn't call it mixture type problems then. We're continuing on with applications of linear systems, where we make equations and then solve linear systems to get answers to situations. As usual, the assigned works at the top, they're on the side board there by the little sign that says grade 10 math. And for the applied students, there's graphs there right beside that underneath the insanity Mr. Bob. It's kind of creepy stepping in the room looking around, right? Anyways, just because you're doing video, obviously. So here we go. So we've got an official type here where we've got a mixture problem. So basically there's call it a mixture, if you will, of types of basketballs that are purchased. We have 20 in total purchased for $700 in total. If you know that practice balls, like crappier ones or whatever, are $30 and game balls, the nicer ones, are $50. How many types of each ball were purchased? Right. So whenever you see a question, as I've been coaching you, we've gone through this types of balls, right? So how many of each type? You're going to say, okay, well, let something be practice ball, so that P be the number of practice balls. Someone, by the way, could come up and maybe the supply teacher could press pause as needed, as people are going through this. Okay, so I'll just keep going and you can just pause the video as you see fit. Let G be the number of game balls. Just a number there. Number of game balls. Then now we have variables to work with. We're going to set up equations, right? So let's use this part here and say, okay, well, we've got 20 balls in total. They have a value or cost $700, right? So if you think of it, you have a total money equation, I guess you could think of it as. And the trick for this one is to think of like, okay, well, how much would it cost if you bought P practice balls? And you'd be paying this $30 P times. It's a little weird to think of, it's abstract, right? But if you bought 2 of them, you're paying 30 twice, so it'd be $60. If you bought P of them, it'd be P times, so 30 times P, right? So 30P is the cost for buying P practice balls, right? So let's add that in. This is the money or cost or whatever of P practice balls. So we have 30P, and then we have the cost of the G game balls, and that's going to be 50G. And that adds up to a total of 700. And I'm just realizing that I think Ms. Hermantree in for this lesson, so I probably don't even need to do this video, but she can still. Here we go. Just make it easy, right? All right, so the other equation, let's color code maybe that one as blue or something. We have price was that, and the other thing we know is I should have actually done this. Total 700, so that one's basically total cost. Other one in blue would be 20 basketballs in total, and that's actually the easier equation. So it's just the number of balls. And so that one's just like P plus G equals the 20, right? We're able to set up 2 equations here. Oh boy. We're able to set up 2 equations that have 2 unknowns, right? So this is a linear system. We're going to start calling that 2 equations 2 unknowns. which is really what a linear system is. And so we can solve by substitution or elimination or by graphing. So I can say solve by substitution, elimination, or of course, graphing. That's something that the academics might need to still work on a little bit because I threw that in on a C variable, and it seems like people might need to practice that. Okay, so that's the equation set up. I guess I can just keep going. So I'm gonna print this as a full page PDF file. So the way this is set up, you can do by elimination or by substitution. Let's do by substitution. Just should be able to do either way. Should do either actually to show you. Maybe. So anyway, substitution. I might just start with the P plus G equation and solve for one of them. Take away G from both sides. Notice now we don't have any like preferred, solving for Y and all that stuff because they're just P's and G's. So who cares? There's no X or Y preference. Shouldn't have been really ever anyways. So we have that as what P is from, this is from equation 2, if we wanted to label it. Equation 1. So from equation 2, end up with this new version. Equation 2, I just confused myself because it was red. So we're going to put that into equation 1. Right, so it's basically equation 2 going into, so it's like new version of equation 2 going into equation 1. Equation 1 was 30p right out plus 50g equals 700. So p 20 minus g is going to go in there. 30 is 20 minus g plus 50g. Equals 700. We're going to work towards solving for G at that point, right? It's ready to go for us. So pause if you need to as you're working through this, of course, like I said. Cross, you're going to get 600, get 30, actually take away 30G. And plus the 50G. And 700. So 20G left over there, minus, oh no, it's plus, right? So we're going to have the 600 plus the 20G from combining the G's, and take away the 600 from both sides. And that with 20G equals 100. We just divide both sides by 20. And just 5. Just show off my new calculator I got ready for my online class. Right, so there's your 100 divided by 20. Look at that. Isn't that nice? Right, so that shows us that we have 5 game balls. We're going to do a conclusion statement to do this kind of question for sure. And then, of course, we need to say here then, what's the number of practice balls, right? And so we have an equation that we made nicely for that, 20 minus G. So the G value just in there. And we have P equals 20 minus 5, giving us 15 of those. Right, so therefore, the number of, practice balls is 15, and the game balls is 5. Right, well, that is, a mixture type question. Yeah, here you go. So take a look at that one for a bit, pause if needed, and press play when you're ready, once you've tried it. We've got a mixture of M&Ms and peanuts being mixed together by a store owner. A total of 10 kilograms of mix to be made with a total value of $38. Their cost, the owner's cost. The M&Ms cost $5 per kilogram, and the peanuts cost $2 per kilogram. Determine the number of kilograms of each needed for the mixture. If you want it to cost $38 wholesale, you're marketing it up as a business person, of course, to make some money. That's what businesses are for. All right. give that a try, press pause, and then come back. I'm gonna walk through a solution that's already written up. All right, so here we go. So this one here, same idea. We're asked a question, and what's the number of kilograms of each? So let M be the number of kilograms of M&Ms, not M be M&Ms, M be the number of kilograms, and P be the number of kilograms of peanuts. Totally okay with these dittos going on here, just same sentence structure. I'm totally fine with that. And yeah, so then we have two types of equations. We've got a total number of kilograms equation, M plus P is 10. And we've got a cost equation, M kilograms times 5, or the, times $5 per kilogram, and 2 times the P for $2 per kilogram times the number of kilograms of peanuts equals the total cost of $38. Boom, two equations, two unknowns, solve linear systems, substitution, elimination, graphing, whole bit. Okay. And yeah, so that works out. This one I did by elimination, subtract the two equations. I multiplied both sides by 5 here. And yeah, ended up with 3p equals 12, so equals 4, then M value, and so on, right? So at the end here, therefore, just like I did last time, right? Therefore, the number of kilograms of peanuts and M&Ms is 4 kilograms, 6 kilograms respectively, something like that. Okay. So that should work. Something just to be able to do. But it's this trick of looking at what they're asking and converting that into variables. Almost always is cookie cutter approach. You could just do that. Unless they ask it in sort of a different way. They might only ask one of the numbers and to sort of interpret and realize there's another number that you could or need to assign to the variable as well. And then this one here, blank page version of that one, I think. Yeah, I do. So yeah, there you go. On that one. And this is a mixture of investments. Okay, so we've got one that earns 2%, 5%, a total of 4,000 invested. So obviously you're going to have like the amount in one, the amount in the other is 4,000. And then you get the total interest earned is 164. So you have to look at how to get percent of a number, which shouldn't be a starting point for you. So yeah, when you're ready, here we go. So we've got the total value equation. A plus H is 4,000. 2% right here, 2% of the amount invested in the savings account, A per account, and 0.05 H for, amount in a high interest savings account. Just do some kind of lettering that makes sense to you. So that A for account and H for high interest, whatever. Something usable, something representative of what we're talking about. Two equations, two unknowns, solve, and so on. This one isn't solved out, but solved by substitution or elimination or by graphing or the applied group. Okay. So applied group, if you need help with graphing, I'm sure Ms. Ferntree can help out with that if that's who it is. In fact, who ended up coming in. Fingers crossed, that'd be good. Not that whoever's there is any worse. Just kidding, whatever. So the graphing version of things, though, just realize, of course, you want to, the idea of it, you have the P equals, this one is easy to do, right? So take away G from both sides. Say that P equals negative G plus 20. So you have a y-intercept of 20 and a slope of -1. So if the intercept is at 20, you have a slope of over 1 down 1 over. Graphing that line there, and then the other one you have to solve for P, and you'll have, that's do part of that too. You want 30P plus 50G, 700. So we're going to solve for the 30P by subtracting both sides. So let's do the negative 50G. Keep it in the same order as the y cos mx plus b equation here for you. And divide both sides. So divide that by 30. So you can have a P equation where you've got a slope of like negative 50 over 30 or another is negative 5 over 3. And then you're going to have 700 over 30 as your y-intercept. Plot it and see where they cross, right? So the 700 divided by 30. This thing here, it's not working for me. It's better. Try again. Maybe. There we go. Yeah, there we go. 700. Right, that's getting in the way. There we go. Get rid of those. So clear that 700 divided by 30 equals the 116.66. So you're gonna have to, graph a much larger scale. It's gonna have probably a steeper slope at that point. Then it's gonna cross wherever it crosses, right? Something like that. So it's gonna cross at 5 and whatever it was before, 5 and 15. So maybe that's it. I haven't totally thought it through, but that would be your 5 and 15. Okay, so approximating by graphing, like I said, there's graphs to be able to do that. When you get your equation, choose a scale that's reasonable, right? If you need to have a y-intercept of 116, then whatever the number was, 117 or so, make it happen. All right, so hopefully that works. The lesson handouts are over here on the side, 14 ready to go for you. See how it goes. All right, I'll be back after the weekend, of course, to help out. Message me on Teams if you need anything, and we'll see you later.